This video will demonstrate the most common types of precision measurements and will show you how to use different types of measuring tools while checking actual components. Auto manufacturers give specifications or measurements for all major assemblies, engines, transaxles, rear axles. If part measurements are not within spec limits, repairs or adjustments would be needed. If you fail to make a measurement, that part could fail and cause a breakdown and expensive time-consuming comebacks. Pressures, temperatures, part clearances, and torque values are all critical. The day of the shade tree mechanic is over. Only well-trained technicians can hope to survive in this complex area of employment. Here's a dramatic example of someone not knowing how to make a precision measurement. This novice failed to measure bolt torque during an engine rebuild, and a rod bolt snapped off during a test drive. Engine self-destruction resulted. The rod was crushed by the spinning crank, and the piston slammed into the cylinder head. Remember, taking the time to measure properly will increase work quality and profits. Rules. Rules can be used for rough measurements. Linear measurement is sometimes done with a steel rule when accuracy is not critical. A small pocket rule is handy for many jobs. It will read to an accuracy of approximately 1/64 of an inch. If more precision is needed, you'll have to use another tool. Here a mechanic is quickly checking valve margin width. If too thin, the valve would have to be replaced. A tape measure expands to several feet or meters in length. It might sometimes be needed for very large measurements during body, suspension, and exhaust system repairs. This mechanic is measuring clutch diameter so that he can order new parts. Calipers. Calipers vary in design. These are for use with a rule. Outside calipers can be fitted over a part and then checked with a ruler scale. Inside calipers are used in the same way. Again, accuracy is only up to 1/64 of an inch. A dial caliper is a much more useful type of measuring tool in auto mechanics because it will measure with an accuracy up to 1/1000th of an inch. Each line on the dial scale equals 1/1000th. This design will make an outside, inside, or depth measurement. To check accuracy of the tool, close its jaws. With the jaws closed, the dial should read 0. If not, adjustments would be required. To read a dial caliper, you must add the ruler scale reading to the dial reading. For example, let's measure spring free length. The rule shows a reading of 2 inches plus less than 1/10 of an inch. A full line is not showing on the scale. This would tell us that the reading is 2.0 plus the dial reading. Since the dial is showing 98 thousandths, spring free length would equal 2.098. A digital caliper will give readings as a number in the display window on the tool. It is easier to read than a conventional dial caliper because you do not have to add the 2 readings together. This tool operates off a trigger grid embedded under a protective coating on the tool body. As an example, let's measure the clearance and wear inside this used oil pump. First, use the outside jaws to measure rotor outside diameter. The reading shows 2.621. You would note this measurement to determine clearance. Next, you'd measure the inside diameter of the pump body. Install the caliper and open it. Keep moving the caliper to get maximum reading of the inside diameter. Here our reading is 2.625. This would show us the rotor-to-body clearance of 4/1000ths of an inch. 2.625 minus 2.621, which was our first reading, equals 0.004 clearance. This tool will also read in millimeters. By pushing the button, the display window converts to millimeters. There are hundreds of measurements which can be made with a good set of calipers. Make sure you have a set in your toolbox. Micrometers. A micrometer, nicknamed a mic, is needed for numerous types of precision measurements. A micrometer will easily measure to an accuracy of 1/1000th of an inch. With a vernier scale, it will measure to 10/1000ths of an inch. For example, when checking piston pins, service manuals commonly give specifications in thousandths and even 10/1000ths of an inch. You must always refer to the correct service manual to get accurate values. The basic parts of a micrometer are the anvil, spindle, sleeve, thimble, and the frame. It is very important that you hold a micrometer properly. You should wrap 1 or 2 fingers around the frame. Then you can use your thumb and finger to turn the thimble. When making measurements, it is very important that you do not over-tighten the micrometer. You can use the ratchet mechanism on the tip of the micrometer to make sure that you do not over-tighten it. To read a micrometer graduated in thousandths of an inch, you must use 4 basic steps. First, read the largest number visible on the sleeve or barrel. Count the number of full graduations to the right of the sleeve number. Then add your thimble reading. As an example, let's read this micrometer scale. First, a 1 is showing. This would equal 1/100,000ths of an inch. We also have 3 thimble lines showing. Each equals 0.025 for a total of 1.75, and finally a 3 is showing on the thimble. This equals 0.003 of an inch. Adding, we get a total of 0.178. Can you read this micrometer? A 3 is showing on the sleeve. Only 2 full lines are showing on the sleeve, and 20 is aligned on the thimble. What do you think the mic is reading? If you said 370,000ths of an inch, you're correct. 300,000ths plus 2 lines equal 50,000ths plus 20,000ths on the thimble equals a reading of 0.370. To read a metric micrometer, use the same principle. However, measurements are in millimeters. Here, a 5 is showing, which equals 5 millimeters. Only 1 line is showing to the right of the 5, and each equals 0.50 millimeters. Adding the thimble reading of 28/100ths of a millimeter, we get a total reading of 5.78 millimeters. Can you read this metric micrometer? A 5 is showing, which equals 5 millimeters. Approximately 0.45 millimeters is showing on the thimble. The total reading would be 5.45 millimeters. A digital micrometer is easier to use than a conventional micrometer because you do not have to add numbers together to get your reading. Turning the thimble makes a digital readout indicate in thousandths of an inch. Numbers are not needed on the sleeve and on the thimble. You can simply read a decimal number in the display window. This reduces the chance of mistakes. This mechanic is miking some valve adjusting shims for an overhead cam engine. You would have to make this measurement to adjust the valves on many late model engines. Micrometer accuracy should be checked periodically, or if you've dropped a mic. Standards or precision gauge lengths are available for checking mic accuracy. Insert the standard into the mic and close the spindle. The mic should read 0 if it is accurate. Some mics have an adjustable anvil to correct for error. You would have to adjust the anvil if the mic did not read 0 when miking the standard. Remember to hold the mic properly and make sure it is square on the part being measured. Lightly turn down the thimble to produce a slight drag over the part. We're miking a piston in this example. Practice will make you proficient at using a micrometer. You can also use a mic as a gauge for rapid checks of sizes. Adjust the mic to specs. For example, the minimal journal diameter for this camshaft. Then lock down the mic. Slip the mic over each bearing journal. If a slight drag is produced over each, their sizes are acceptable. You would know that none of the journals are undersized or oversized. Telescoping and hole gauges. Telescoping gauges can be used to measure diameters of large holes or bores in parts. Various sizes are available for different jobs. You must select the gauge with the correct size range. The telescoping gauge has a lock screw on one end. When released, the gauge will telescope in and out. When tightened, the gauge will not move and can be measured with an outside mic. Let's measure the diameter of the bore in an engine block. Insert the gauge into the bore. Hold it at a slight angle and lightly snug down the lock screw. Pull the gauge up until it is perfectly straight in the bore and then out of the cylinder. Fully tighten the lock screw before miking it. Use an outside micrometer to measure the telescoping gauge and get your bore diameter measurement. Your mic reading will equal bore diameter. An inside mic will do the same thing as a telescoping gauge, but it is not quite as convenient to use in deep openings. It is read like a conventional micrometer after adding the spindle length to the reading. Adjust the mic out until you feel a slight drag when moving the mic square in the cylinder. Then read the sleeve and thimble as you would a conventional mic. Remember to add the length of the spindle rod to the reading. A small hole gauge is similar to a telescoping gauge, but it will measure smaller openings in parts. For example, we'll use a hole gauge to measure a valve guide in this cylinder head. The hole gauge will expand and contract as you turn an adjustment screw. Adjust the gauge to drag slightly in the hole or guide. Then remove and mic the hole gauge. Use an outside micrometer to measure the size of the hole gauge. Hole gauge size would equal valve guide diameter in this example. Adjust the mic down for slight drag on the hole gauge. Read your mic to determine the diameter of the valve guide. Hole gauges are also available in several sizes for making numerous measurements. To determine valve stem clearance in our example, you would have to subtract valve stem diameter from the valve guide diameter measurements. This would give you a very accurate reading of the amount of clearance between the valve stem and the valve guide in the cylinder head. Feeler gauges. A feeler gauge has precision pieces of metal equal to specific thicknesses, given in thousandths of an inch or hundredths of a millimeter. The thickness of each gauge is printed on the side of the blade or next to the wire. Both flat and wire-type feeler gauges are needed in auto mechanics because each has its own advantages. A flat feeler gauge is used to measure distances between parallel parts, like these contact points. To adjust contact points, you would turn the distributor shaft until the points are fully opened. Then insert the correct thickness gauge between the points. A slight drag should be produced as the gauge is pulled in and out. Adjust the points if needed. A non-magnetic feeler gauge is needed to adjust the air gap in some electronic ignitions between the reluctor and the pickup coil. A non-magnetic gauge is needed to prevent the pickup coil magnet from pulling on the gauge and producing a false reading. Slide the specific size gauge between the air gap. The reluctor tooth must point directly at the pickup coil. If the gap is too large or too small, you can adjust the pickup coil distance from the reluctor wheel by loosening the screw and using a small screwdriver in the slot. A flat feelers gauge can also be used with a straight edge to check for part warpage, as when checking engine castings for flatness. A straight edge is precision ground and is very accurate. For example, let's check the cylinder head for warpage. First, we would select about a 3/1000 feeler gauge. Then we would position the straight edge on the deck surface of the head. You must check the head in several locations. First, lay the straight edge straight on the head to one side. Then try and slip the feeler gauge under the straight edge. Check on the side, in the middle, and then on the other side of the head. Then turn the straight edge at an angle. Try to slip the feeler gauge under the straight edge. Then check across the head in the other direction. This will check every plane for warpage. If your flat feeler gauge does not fit between the deck surface and the straight edge, the head is not warped and does not have to be milled. Here's an example of a badly warped head. Overheating caused the head to distort. As you can see, the gauge easily slides between the deck and the straight edge. Head milling or replacement would be needed. You should also check other mating surfaces for warpage. The exhaust mating surface and the intake side of the head could be checked for warpage. You might also want to check the intake and exhaust manifolds. They too can warp and cause leakage if not measured. A wire feeler gauge is commonly used to measure the distance between irregular surfaces. For example, on this spark plug, you would select the correct thickness gauge, insert it between the parts, this plug gap for example. If needed, bend the side electrode until the gauge is touched by both electrodes on the plug. Dial indicators. A dial indicator will measure part movement in thousandths of an inch or hundreds of a millimeter. The needle on the indicator face registers amount of plunger movement. This makes it ideal for checking gear teeth backlash or clearance, shaft end play, cam lobe lift, and other similar kinds of part movement. The indicator face can be zeroed once the indicator is mounted on a part. You can turn the face to zero the indicator. It also has a swivel head for positioning the indicator face to contact the part properly. This high-quality indicator has a universal joint type arm. It will flex into various positions and hold its position accurately. To release the flexible arm, you'd simply move the lever. This would allow you to position the indicator directly on the part to be measured. This indicator also has a magnetic base, which is handy for mounting on ferrous components. By simply pushing the button, you can release the magnet or apply the magnet. The magnetic base saves time over older clamp-on type bases. This unit also has a thumb screw for making fine adjustments of indicator position. This is a less expensive indicator that uses a solid shaft arm mechanism. Thumb screws allow you to loosen the arms and position the indicator on the part. You can swivel the indicator into different positions or move the arms into different positions. The indicator face is also rotatable for zeroing the indicator plunger once positioned. Note that this plunger has a wide base. This is handy when trying to measure thin or sharp-edged components. V-blocks can be used in conjunction with a dial indicator to measure shaft runout or to find out if a shaft is bent. For example, let's check this camshaft for runout using the V-blocks. Mount the camshaft into the V-blocks. Then position the indicator to ride on one of the camshaft journals. Zero the indicator face. Lock down the thumb screw, then rotate the camshaft while watching the indicator. Note that this camshaft has almost 2/1000ths of an inch runout. This shows an egg-shaped journal or a bent camshaft. If this camshaft had not been measured, it could have caused problems when installed in the engine. Cam bearing and journal overheating could have resulted causing failure of the cam or the cam bearings. Here's an example of how a dial indicator can be used to measure gear clearance on a rear axle or differential assembly. Mount the indicator's magnetic base on the carrier and position the plunger to contact one of the ring gear teeth. The plunger should be in line with gear rotation. Then wiggle the ring gear while holding the pinion gear stationary. Needle movement equals gear backlash for teeth clearance. This ring gear has approximately 12/1000ths clearance. If needed, you could increase or decrease gear clearance by turning two large nuts with a spanner wrench. Here's another example of measuring runout or wobble. This unit shows about 2/1000ths runout, which could possibly cause problems. Some service manuals recommend checking valve stem clearance with a dial indicator, rather than a hole gauge and mic discussed earlier. On aluminum heads, a trick is to use a steel plate for mounting the dial indicator's magnetic base. The magnet won't stick to an aluminum head. Position the indicator so that it is parallel with the rocker arms and point of maximum valve guide wear. The valve should be pulled open to a specific amount, typically about ½ an inch. Then wiggle the valve sideways while reading the indicator. Note that the indicator reading is not exact valve-to-guide clearance, but it is a larger value. Therefore, you would have to refer to a manual to get an exact specification. This is a cylinder gauge. It can be used to quickly measure the taper and out of round in the cylinder. By sliding the tool up and down in the cylinder, indicator movement will show taper. Usually a cylinder will wear more at the top than the bottom because of less lubrication. If excessive, power honing or boring would be needed. By turning the indicator sideways in the cylinder, you can also check out of round. Any difference in the vertical and horizontal readings of the indicator would equal out of round. Torque wrenches. Torque wrenches are commonly used for measuring the twisting force applied to fasteners. This is a very accurate dial-type torque wrench. Never look at an angle like this when reading the dial, however, because parallax error will result. Always look straight down at the dial to make sure your bolts and nuts are tightened right on the money. This is a click-type torque wrench. It is faster than a dial-type torque wrench, but not quite as accurate. Torque values on the adjustment are in pound-feet, but a conversion chart allows changeover to Newton meters. To adjust the wrench settings, simply turn the thumb screw until the reading is equal to spec torque. This tool has a handy ratchet head for speed, and also allows you to torque left-hand threads, and a swivel head for torquing in tight quarters. When using a torque wrench, apply a smooth, even pull to the handle. Do not jerk on the wrench or false readings will result. Support the head of the wrench without touching the handle. Plastigauge. Plastigauge is a time-saving measuring device for checking clearance between two parts. It is frequently used to measure engine, rod, and main bearing clearances, for instance. Note that the paper wrapper has a measuring scale. Each scale represents a small clearance. 1/1000th of an inch, 1 1/2 thousandths, 2 thousandths, and 3 thousandths of an inch. The plastigauge itself is inside the paper scale. It is simply a precision diameter piece of plastic-like material. To use plastigauge, tear off a short piece. Install the plastigauge on a clean, dry, unoiled journal. It should lay across the journal. Then install and torque the cap. Again, the bearing should not be oiled to get an accurate reading. Do not rotate the parts while the plastigauge is installed, or you will smear and ruin the plastigauge. Remove the cap and compare the crushed plastigauge to the scale. This bearing has 1 1/2 thousandths clearance. Pressure and vacuum gauges. Pressure and vacuum gauges have many uses in today's automotive shop. This gauge has a vacuum gauge on one side, which reads negative pressure, and a pressure gauge on the other side of the scale. This is a high-pressure gauge, which would be needed for modern electronic fuel injection systems. Unlike older mechanical fuel pumps that produce only 12 to 15 pounds per square inch, or psi, modern electric pumps easily produce up to 50 psi. Make sure your gauge reads sufficient pressure before testing. This pressure gauge has a special hose and fitting for installing on the fuel injection system, Schrader, or test valve, usually on the fuel log. It also has a bleed-off line to release high fuel pressure before disconnecting the gauge. Pressing the button releases the fuel into the clear hose for safety. Here's a common compression gauge for checking the mechanical condition of an engine. Note that it will read even higher pressures. A low reading might mean a burned valve, worn rings, blown head gasket, or other trouble. This gauge has a removable hose that screws into the spark plug hole. A valve in the hose holds cylinder pressure. A quick disconnect allows easy connection and disconnection of the gauge hose and the hose installed in the engine. A pressure relief valve on the gauge fitting is also provided. Temperature measurement. Temperature measurement is needed with modern automobiles. This digital pyrometer will make accurate and rapid temperature measurements. Pressing a button produces an instantaneous digital readout. Different probe designs are provided. A flexible probe for checking fluid temperatures, a contact probe for part temperature measurement, and an air probe. Each has several functions.